Hello everybody, this is Mr. Folly, and I'm digging out my calculator, so I hope you're digging out your calculator too, because we're going to be calculator and fools. Okay, got mine. Alright, let's do these. I'm going to show you the heating curves and the answers to all of it, so let's take a look at it. Calculate the energy and calories required to change 15 grams of ice at -10 to 15 grams of water at 0. So remember, the first thing you do is 1/4 is the boiling point. I'm sorry, I guess that's 3/4. And at 1/4 is the freezing point. And I'm going to start at -10. And I'm going to end at water at 0. So I'm going to end right here. First dot is here. I'm going to end there. Now, I went all the way over there because I start as ice. So I got to go up, boop, over. So I have two parts. The yellow part, come on, Q equals MC delta T, plus, and then this part is going to be M delta H. Now it's going to be delta H fusion because I'm dealing with ice, which is a solid. So here we go. Mass is 15 in each spot, so 15. Specific heat of ice. So when I'm looking for specific heat, this is my specific heat part. Here's solid, so 0.5. 0.5, 0.5. Change in temperatures from -10 to 0, which is 10. Plus mass, still 15. That'll always be the same. And the heat of fusion, and calories per gram is 80. And I get out my calculator, and I get it. 15 times 0.5 times 10 equals, plus quantity, 15 times 80, quantity equals 1275. How about that? 3.20 calories of energy is added to 1 gram of ice at 0. How much water at 0 is produced? How much ice is left? So notice we're at 0. And remember how we have freezing point, 0, boiling point, 100. I'm going to start as ice, and I'm going to end as water. So that's it. There's only one equation. So I'm going to have Q equals M delta H fuzz. So 3.20 calories of energy, 3.20, is added to 1 gram of ice at 0. How much water is produced? How much ice is left? So I want to know how many grams melt. So I'm going to do this. This will tell me how many grams melt. And the heat of fusion is just like it was in the last problem, which is 80. So my mass is 3.20 over 80. And it's going to be 0.04 grams melt. It says how much ice is left. 0.96 grams of ice remain. All right, so calculate the energy in calories when 45.2 grams of steam at 100, that's the boiling point, condenses to water at the same temperature. So again, notice this is no temperature change. So my freezing point, which is 0, my boiling point, which is 100. I don't change temperature. I just go from steam. It doesn't really matter which direction it goes, but I'm just pointing out that it goes this way. Condenses to water. So I'm only changing state of matter, so Q equals M delta H. I have a gas, so it's vaporization. My mass is 45.2. My heat of vaporization for water is 540. Calculator away. 45.2 times 540 is 24,408. 24,400 calories. That's calories. What is the energy in joules? We do not need to do the joule part. Okay. Why do different compounds have different boiling points? I suppose I'll write in there. Why different compounds have different boiling points? They have different intermolecular forces. Require different amounts of energy to break. So if you remember, dispersion takes less than H bond. All right. A piece of gold weighing 35 grams absorbs 185. We're going to change all of these into calories. When its temperature increased by 41 degrees. What is the specific heat of gold? So I'm going to do Q equals MC delta T. We keep jumping back and forth from on this. So my mass is 35. I'm solving for the specific heat of gold, so it's 185. And you can't just change that, but we don't use joules at all in this class anymore. I'm going to solve for C. And the temperature increases by 41, so that means the change is 41. It doesn't increase to 41 from something. So what I'm going to do is I will solve for C. So to get rid of these things, I'm going to divide that 185 by that. 185 divided by 35, divided by 41. And C, which should be small, 0.129 calories per gram degree Celsius. Notice how evil that unit is. All right. Temperature of two substances, calories per gram degree Celsius. Two substances of the same mass increase by 20 degrees when heated. Which absorbs more energy? Substance with a high specific heat or lower specific heat? The higher C, because it takes more calories to raise 1 gram 1 degree Celsius. So notice how the unit is calories per gram degree Celsius. So the higher specific heat takes more calories to raise 1 degree Celsius, which literally is what that means throughout the whole thing. The human body is approximately 60% water. Explain how this high percentage of water helps the body handle rapid changes in outside temperature. Water has a large specific heat, so it takes a lot of energy to change the temperature. Constant temperature is favored. So, if your temperature changes to like 100 degrees, your blood will boil and all this other stuff. So you get the idea. Skill bacteria, the temperature of the liquid water inside an autoclave must be 120 degrees. How is this possible when water usually changes to a gas at 100? Remember, there's two things that impact boiling point. One is temperature, the other one is pressure. For a long climb to the top of Mount Everest, you are hungry and want to make frozen ravioli for dinner. You boil ravioli for 10 minutes according to the directions, but notice the ravioli are still not fully cooked. Explain. So, if this is my pot of boiling water, bubble, 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 and I have all this air pressure on it, this is going to be P big, and I know that boils at 100 degrees. Now, if I'm on a mountain, boop, 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 boiling my water, doo, 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 this is P small. Okay? So what that means, instead of boiling at 100, because there's not as much air stomping it down, it's going to boil at 90 degrees Celsius. Okay? So if you cook at a lower temperature, you must increase the time. Which is why we have a higher vapor pressure at room temperature. Remember, vapor pressure means evaporation ability. So which one evaporates more? Motor oil or water? Water evaporates, motor oil doesn't. Paint thinner or vegetable oil? Paint thinner evaporates, it smells more. Vegetable oil smells less, evaporates less. Perfume smells, evaporates more. Water acetone is fingernail polish remover. And that evaporates very quickly. By the way, this just snuck out of my test and on this worksheet, and it shouldn't have, but there we go. That won't move. Yay. Well, too bad. Use data table provided to answer 11 through 16, which is the same one as there. What will happen to sodium as it is heated from 50 to 800? So just as what will happen to it. So this is my boiling point. This is my freezing point. So we're looking at sodium. Sodium. 98 and 889. 98, 889. What happens if it goes from 50 to 800? 800. So it's got to go up, over, up. So what will happen to it here? A solid warms, it melts, and a liquid warms. It does not boil because it doesn't get to 889. How much energy will be released when as 45 grams of water cool from 132 to 14? 100, 0. So I'm starting at 132, bump, 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 and I'm going down to 14. Bump, 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 bump. I have 3 line segments, so I have Q equals the first one, MC delta T, the next one, plus M delta H. Okay, so I'm at the high boiling point, right? 132. This is condensing, so I've got a gas, plus last part right here, MC delta T. So my mass is 45 grams. But I put a little G outside of there. I didn't need to do that. 45 grams. Specific heat of the gas. Here's solid, liquid, gas, specific heat. The specific heat of gaseous water is 0.5. Oops. 0.5. The change in temperature from 132 to 100 is 32. Plus the mass is still 45. We did before where the heat of vaporization was 540. That's on the table. Plus still 45 grams here. Liquid water specific heat is 1. Change in temperature is 100 to 14, which is 86. So again, heat of vaporization is 540. Specific heat of liquid water is 1. Calculators assemble. Told you needed it. 45 times 0.5 times 32. Enter. Plus quantity 45 times 540. Whoops. Close. Plus quantity 45 times 1 times 86. Oh no, I forgot my parentheses. Times 45 times 86, close parentheses. I put 48 times 86. I know I typed it in wrong. 45 times 0.5 times 32, enter. Plus quantity 45 times 540, close quantity. Plus quantity 45 times 1 times 86, close quantity, 28,890. All right, how much energy is needed to boil 53.5 grams of bromine at 65? So check out bromine's stats. Bromine at 63 degrees. Hey, that's where it boils. So, oops. So the BP is 63. All I'm doing is boiling it. So that means I have one equation, Q equals M delta H. I'm boiling, that's got a vapor, vap. I've got 53.5. And you may think the delta H vap is 540. That's water. Bromine has different intermolecular forces. So bromine's heat of vaporization is a lot less. It's weaker, 44. So 53.5 times 44 is 2354. How much energy is released as 20 grams of copper cooled from 2250 to 1200? Check out copper. Copper's boiling point 1080 and 2582. 2582, 1080. Let's see. We go from 2550 below to 1200. All that is Q equals MC delta T. Mass of copper is 220. Specific heat of copper is, it's liquid. No, I'm in the middle, right? Yeah, it's liquid copper is 0.1. It's 0.1. The change in temperature is 2550 minus 1200, 1350. Do the math here. And 220 times 0.1 times 1350 is 29,700 cal. All right, two left. How much energy is needed to heat 15 grams of mercury from minus 55 to 350? So mercury stats. Oops. Mercury stats. Negative 39 and 357. So, oops. Negative 39 and 357. And I'm going from negative 55, that's low, to 350. Up, over, up to 350. So that's going to be Q equals MC delta T. This is a solid plus M delta H fuzz plus Mc delta T liquid. So now I need my mass. Mass is 15. Specific heat of solid mercury. Gonna buy me a Mercury and cruise it up and down the road. So it's 0.030 and 0.034. So 0.030, just because I'm going to use it over here, 0.034. Change in temperature was from negative 55 to 39. So 55 minus 39 is, I hit log, that's not going to work. 55 minus 39, it's going to be 16. Plus still 15 grams. Heat of fusion of mercury is 2.8. That's not very big. Plus 15 times specific heat, 0.034 times, from 350 minus 39 is 311. Information. That's 411. 15 times 0.03 times 16, enter, plus quantity, 15 times 2.8, close quantity, plus quantity, 15 times 0.034 times 311, close quantity, equals 207.81 calories. There you go. Oh, I got one more. How much energy is released from 25 grams of CCl4? CCl4. Magic number, CCl4, boom. Negative 24 to 77. Negative 24 to 77. You get out of the video.
What's up, video?
Hey, that was people. I'm going from negative 15, to negative 40. So I have three things here. Q equals MC delta T. Notice I'm cooling this time. It's kind of weird. Q equals MC delta T plus M delta H, the freezing point, right? Freezing is fuzz, plus MC delta T. This is the solid. This is the liquid. Boom. Mass is 25. Specific heat of CCl4 liquid. CCl4 liquid, 0.2 and 0.2. 0.2, oops. And then that's 9 degrees. To get from here to here is 9. Plus 25, heat of fusion of CCl4, 4.1, plus 25. This was 0.20 as well. And then I went from 24 to 40, which is 16. It sounded like that hurt out in the hallway. 25 times 0.2 times 9, enter, plus quantity 25 times 4.1, close quantity, plus 25, plus quantity 25 times 0.2 times 16, close quantity, and I get 227.5 calories, all worked out and explained. Toodles.